Alright, so this is section 1.3. We've part B. Part A, we went all the way just before 26. So we're going to keep pushing, starting 26 till the end. Okay? So, I understand this was covered in the tutorial, so if you wish to skip, or if you don't fully remember, or if you didn't quite get it, this is a good chance to catch up, so to speak, right? So, 26. We have a 6 by 6 matrix. And then we have 4 different conditions that we need to satisfy: A, B, C, and D. I know D was omitted, but I don't see why. It's kind of fun to think about it, right? So, anyways, so let's start with A. It says Aij must be 0 if I cannot equal to j. Okay, so I and j, as we remember, is I is the number of rows and j is the number of columns, right? So, interesting enough, I cannot equal to j. So, what I deducted was that, yeah, that's what I meant to say, is that if you look at this diagonal, right? 1 by 1, 2 by 2, 3 by 3, 4 by 4, because the length, because it's like rise over run, right? The slope is perfect, so, if it's 2, then it's 2. If it's 3, then it's 3. If it's 4, then it's 4, so forth, right? This line is the only case where I and j would be equal, right? So I figured, okay, so this condition must apply to anywhere except these lines, right? And if it's not, if the row and the column numbers don't match, then it's 0, right? So basically all you have to do is, okay, so everywhere 0 except this diagonal line. So, I mean, you could draw the whole thing, but, I talked to Carlos and he's cool with this too. Right? Maybe give more description as to what this line means, right? So this is a diagonal, blah, blah, blah. So where, where it's like I, j, where I equals to j. You can say that. So, that works too. Oh, that's a big fat 0. This literally means all entries are 0, because that's what it says over here, right? So that's the case so that's a simple way to start. B. So different condition, similar idea. A, I, j equals 0 if I is greater than j. Well, okay, that's pretty. Okay, let's get into it. I is the number of rows, and j is the number of columns. I know I keep repeating, but mostly for myself, not for you guys. I'm sure you guys are like all prepped. It's like, oh, I know all this stuff. I just need to connect the dots, or just indulging this guy because he's trying hard with the YouTube. So. Anyways, I'm just kidding. YouTube is not that hard. It's just uploading and trying to find the time to make this work is the hard. Explaining isn't that difficult. It's like just doing homework questions, right? So don't feel bad. Not that you would, but So if that's the case, so row has to be greater than column. So if that's the case, let's see here. Look at all these places. Where is the row bigger than j? So for example, look at 1, 1. Does this work? No. They are equal. 2, 1. Does that work? Well, yeah, because 2 is greater than 1, right? Because this is row and column. I know, I'm an insane person repeating things over and over. Okay, but 3, 1. Yeah, that works too. 4, 1. Do you see the pattern? Let's try the other one. 1, 2. No, it won't work because j is now bigger. 2, 2? No, they're equal. It works here. And if you do the same thing, so this won't work because j is greater, right? You see the pattern? So oppose this diagonal line. Anything that's under works. Therefore, you can just explain it as, so assuming that you explain this in part A, right? And it's on the same page, hopefully, then just say everything here is 0. This is, I don't know, some numbers. All right? You don't even have to write it down. But this is the whole point, right? So that's the idea. Yeah, so it's really common sense for most of these questions, but maybe you need that to incorporate into a question. Who knows? C. So again, same condition, but no. Same idea, but different condition. So it's I is j. So it's the other way, right? So use your common sense. If column is greater than, if row is greater than column in this area, if you flip it, shouldn't be all this side. Let's just check, just to make sure that we know what we're talking about. 2, 1 is greater. 3, I'm sure you can connect the dots, right? So 6, 1, bigger, 6, 2. When does it stop? Right when it's 6 by 6. So all this top, so you could just put, and then you could put some numbers there, I don't know. And then that is going to be your C, right? So on the diagonal line, anything above it will be all zeros, as it implies. You haven't done D because it wasn't assigned, but I thought it was still cool nonetheless. So I'm going to do it. If you want to listen, great. If not, you know what to do. D. So this one's a little bit weird because same idea, but the condition is a little different from the rest. I minus j is greater than 1. Now notice that this sign, right? For people who may not remember math exactly, this is absolute value, right? So what that means is anything inside this absolute value, doesn't matter if it's negative or positive, whatever, eventually it's going to be positive. It's like squaring it, except, you know, the number itself doesn't, magnitude of the number don't change. It's just a sign. It's like, think of it this way, in physics, remember vector and scalar? It's like devolving from vector to scalar, right? So number itself is not affected by the sign change. Sign is always becomes positive, right? So, so I minus j has to be greater than 1. When could that possibly happen? So let's see here. So if it's got 1 to 1, no, that won't work. That's going to be 0. 2 by 1, well, that's 1, but 1 is not greater than 1, right? Let's do 3 by 1. 2 is greater than 1. Yes. So yeah, so 3 by 1 works. I'm going to actually call it because this is my last one. Can I do 4 by 1? Yes. 3 greater. And hopefully we'll pick up the pattern. Let's try the next one, right? So let's say, so we tried all the row 1. Let's try row 2. No, it's negative. Not cool. 2 minus 2, 0. Not greater. 3 minus 2 is 1. No. 4 minus 2 is 2. Now we can work. Right? And 5 minus 2 will be greater and so forth, right? Let's try third column. Again, 4 is 1, so 5, right? 5 minus 3 is 2. It has to be greater than 1, right? Do you see this pattern? Now, a lot of people are like, I'll just stop there, right? But remember, it's absolute sign. So it doesn't matter if I is greater or j is greater. As long as the net, right, whether it's 2 or negative 2, doesn't matter because it's inside the absolute value. So they will both be 2, right? So then, but if the sign can flip, so can this. So let's say, as an example, let's choose the extreme side, right? So I suspect, even without doing calculations, it's going to look like that. So yeah, this will count as well. But, you know, let's check, right? So let's say there was 3 minus 1, 2. Sorry, so it's I minus j, right? So I may be 3 and j is 1. That's 2. Oh, maybe I did the other way around. Yeah, it should be I. Sorry, my bad. So what I was calculating should have been here. This should have been the exact same thing, except it's a minus, right? So, sorry, it wasn't meant to be 3 minus 1 here. So it should have been 1 minus 3 because it's row minus column, right? So, yeah, so that would work. So this, so you would do this. Well, okay. This you may have to be a little bit more specific because diagonal line won't help you, right? Maybe draw another diagonal line or something and just say everything here will be 0. But then you have to specify what this line is and you have to know what this line is, right? So maybe better if you just draw this, right? If you have time. But you understand the concept though, right? So nothing biggie, but I thought that was kind of interesting. So, so that wraps up 26. This is 33. I wish I could like prepare all the questions like this so that I don't have to write and I can just talk about it. But then I have to move my camera all the way, and not all rooms have great boards. So like this. So anyway, so let's try before people start coming in. Okay, so we're gonna do 33. So basically, their question is this. So it's the question's right here. I sort of did some drawings, but you'll figure out why I did that later. So basically, no. I hold it. Okay. All right. Okay, there we go. Okay, there we go. So basically it's just so they gave you the table, right? Type 1, type 2, type 3 versus Jan, Feb, March, April. We're talking number 33 now, right? So this is a matrix, and basically you're timesing by 1, 2, 3, and they're saying, well, if you are times them together, what does that? You have a product. What is that supposed to mean? What does that matrix mean, right? So let's try to reason it out. So again, this is where the finger multiplication rule comes into play, right? So I'm gonna do that, right? So row times column, right? So if I do this, see my first finger, right? Always hits 1. Actually, no, this one it doesn't really matter because you're doing times by that times row times column because there's only one column, so you don't really have to worry about the finger this one. But row times column, and then the first row times first column should be. Oh yeah, before we even talk about that, right? Actually, we should talk about what the net matrix looks like. This is 4 by 3, and this is 3 by 1, right? So, based on what we learned about multiplication, these two cancel. So you gotta have something that has 4 by 1, right? Which is this one. This is actually the answer, but let's not get there yet, right? So it's 4 by 1. So these are the calculations as to what the 4 by 1 will look like. So this looks complicated, but all I did was 3, 4, 3, 1, 2, 3, right? So that's 3 times 1, 4 times 2, and 3 times 3, and just add them together. That's all there is. So this will be one entry, this will be second entry, third entry, 4 entries. So there's column, row 1, 2, 3, 4, and if you add them all up, the entry will be just 1, so you have a single column, right? So we got the sizes all figured out. Now we need to figure out what those entries mean, right? So here's an interesting thing though. If you look at these number patterns, 3 times 1, 4 times 2, so we all can figure this one from basic multiplication, right? 3, 4, 3. Where are they all from? From the first row, 5, 6, 0. Second row, third row, fourth row, right? So what does that mean, right? What do each rows represent? Each rows represent the month, right? So this is something to do with January. I don't know what it is exactly, right? In January, there's 1, 2, and 3. What is that supposed to mean? What is 1, 2, 3? You probably noticed if you read the question, type 1 costs $1 each, type 2 costs $2, and type 3 costs $3, right? So it kind of makes sense. In January, for example, in January, there were 3 types made, right? And they're gonna each cost $1. So in January, type 1 will cost $3. Type 2 will cost not $4, it will cost $8, right? Because 4 times 4, and there's 4 of the type 2s, and each of them costs $2. And same thing for type 3, right? 3 times 3, because each costs $3, right? So think about that. You're adding total cost of type 1, type 2, type 3, all in January, right? So if that's the case, use the same concept, and you'll say, oh, so if that's January, well, where did 5, 6, 0 come from? That is for February, right? March, April. So that's why, my conclusion was, so you're going to have 4 by 1. That's cool. First row is all type cost, how much the total cost for all types in January. And same thing, how much do all types cost in February, March, April. That sort of thing, right? Could be very useful if you are running a retails or something like that to calculate your profit margins and predict your sales and stuff like that. So that would be sort of, not predict the sales, but to figure out how much things will cost. So maybe you want to maybe you want to go all out with the sales during the time when it's cheapest to make, and at the same time maximize the inventories. That could be cool. Someone should program that eventually for portfolio. But anyways, but yeah, that's the idea, right? So that's the 33 for you. Pretty simple. And the 34 is exactly the same concept. The only difference is it's gonna... Why is it so zoomed in? Oh, let's go further. All right, I'm gonna have to move this around. Maybe. Okay, but anyways, so now we're on 34. The last question, a long last. A and B should be pretty simple, hopefully, right? So M matrix is a May sales, and then the J represents the June sales, right? So if you add May sales and June sales, obviously that's the total sales you've made for both May and June, right? Notice that because it's addition, matrix size doesn't change. So it's just like looking at May sales or June sales, except individually. So you know, they will tell you how much shirt you sold. No, how much. Okay, so what I mean to say is, so like let's say if you look at the table example 34, just below the question, there's a shirt, 45 is small, 60 is medium, 75 is large. So there's small shorts, 45 small shirts were sold, and 60 medium shirts were sold, and 75 large shirts were sold in May, right? So if you do May plus June, that just means same thing. It's a total. So there were 45 plus 30 because small shirt sold in June is 30, right? So 30 plus 45 will be 75. So there's 75 small shirts sold in May and June, and vice versa, right? And B will be the same thing. You're subtracting it. So because you're doing May minus June, so you're saying how. It's just easier to say when it's right there, right? How many more sales were made in May relative to June, right? So they still have clothes with sizes, right? So what I mean, so they tell you it's going to be small shirts. This many small shirts were sold more in May compared to June. Now I haven't done actually all the numbers, but sometimes sometimes they may have sold less in May than June. If that's the case, then the overall number should be negative, right? Now, does that make sense? You have negative shirts sold? No. But if you understand what it means, then it just means, oh, if it's negative, that just means we sold that many more during June, right? So if the number was like -5, that means, oh, I sold more -5 inventory of that size during June than May. So, you know, actually, wouldn't that be improvement? Because you sold more June than May, so you're actually making more sales as the time goes on. Okay, I don't know. But yeah, that doesn't sound like a very good table. But anyways, okay, so that's that. So let's do the tricky one, C, D, and E, and then we are done. And I can do other things. Okay, but anyways, so C, it says MX. You said times M and X, and then the net matrix should say something about the types of clothes sold. So let's try to figure out what that means. Let's start from the scratch. We know M, so let's start with M as we roll right here. Hopefully this is big enough to see. But yeah, so the dimension is 4 by 3. I roll 3 by 1 because I figured it out, but we don't know that, right? Let's assume we don't know that, right? We do know if we want to multiply successfully though, we should have 3. And we don't know if that's going to be 1. But it's going to be 3 something, right? So if that's the case, right? So let's say we don't know this one, right? This is going to be 4 by something. We don't know, right? But how do we know if it's 1? I mean, it's sort of obvious that it is based on all the patterns that we've recognized. But still, how do we know? Because overall should be types of clothes. What does it say specifically? It says list of number of shirts, jeans, suits, and raincoats sold in May. So just because they want all the different types of clothes sold, right? So first row should be shirt, jean, suit, raincoat, right? So there should be 4, which makes sense because we do get 4 in the beginning. How do we get 1? What does it say? For shirt, how many shirts are sold? Does it say what sizes are sold, anything like that? They don't care. Small, medium, large, just shove them all together. I want to know how many shirts I've sold, which means the column has to be 1. That's why we know the overall should be 4 by 1. And if we know the overall is 4 by 1, then the earlier ones better be 1. Right? That's the only way you get 4 by 1 dimension, through multiplication, right? So that's the case. Then we have to figure out what this is. So we figured out the dimension 3 by 1. So it's x1, x2, x3. I just made those variables up because we don't know that yet. Now, what do these have to be though? We have to be more specific. What do these have to be so that when we do multiplication, it actually shows exactly how many shirts, blah, 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 the different types of clothes are sold. Let's do the multiplication. This is where the hands become handy, right? So 3 hands because there are 3 columns. So I'm going to do this, 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 and this, right? So every time when I do this and this, right, that all goes into entry 1, right? And then second row, and then second row, third row, fourth row, right? So it seems like it's like this times that is going to be the first one. So first one is what? Probably jeans, right? Because this is, oh no, not jeans, shirt, right? Because that's a shirt, right? So all shirts, small, medium, large, whatever, you times all that by some number, and it will give you the total sold. Now here's the thing. How many jeans were actually sold in May? It's 45 plus 60 plus the 75, right? If we don't care about the sizes, right? If we just want to do 45, 60, and 75 so that we have that sum here, what does x1, x2, x3 have to be? They all have to be one, 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 which makes sense, right? So 45 plus 60 plus 75, right? Now, what if they did 2 here? Okay? What does that mean? That means somehow, so medium and large, they're 60 and 75, right? Because 60, 75, right? If you do the multiplication. But 45 is being times by 2. What does that mean? So 45 small shirts were sold, but somehow that has doubled. You know? Either the person trying to take advantage of the commission, or maybe there was an error or whatever, right? So that will cause more shirt to be sold than what it actually is, right? So we have to be careful about that, right? So that's why, but now sometimes we want to put 2 or 3, depends on what we want to get. Here we're looking for how many shirts we've sold. So we want to keep these numbers and just add them. And the only way to do that, make all become 1. Cool. And you will get those results, right? Okay, let's move on to D. Do I need to move a little bit? Oh, a little bit would be nice. Okay, so D is right here. Okay, so it's a similar idea, but now we've changed it. So instead of doing mx, it's going to be y. And according to the question, it says the net matrix should be list of all different sizes of clothes sold in May. Okay. All right. So again, we do the same drill. We know m. Excuse me. So if you have m here, so m, which is the how much you sold in May, and then we have some kind of a matrix y that we don't know. We don't know what it is. It could be the same as the x, probably not. I mean, you know, they're using the common sense, but you know, something, right? So let's understand what this is by size, right? So again, our original matrix is 4 by 3. In order for me to times y by y times m, remember these two numbers have to be the same. So if that's 4, that better be 4. If it's not, we can't multiply, and then, you know, the whole point of this question, we can't even solve this question then, right? So this better be 4. Like, again, I put 1 here just for my reference, but again, it may not be 1. We don't know, right? But we do know it's gonna become 1. So, you know, this is where I start to ramble. Okay, but anyways, but whatever we times it, so like it says, list of different types of sizes of items are sold in May. So, let's look at it. So, this row shows, so, it's going to be size versus how many sold, right? So, here it says number of small, medium, large items. So, this time we don't really care if it's shirts or jeans or suits or anything like that, right? So, because of that, yeah, so because of that, your matrix size should be, so sizes, how many sizes are there? There's 3, right? So there's small, medium, large, and this should be, you know, just how many smalls, mediums, or larges were sold. So because of that, that column should be 1 by 3, right? So because of that, yeah, sorry, someone came in, so I got a little bit started. But anyways, so that's, 1 by, no, sorry, it will not look like that. So this is the column. So it shouldn't look like that. So it should look like this, because it's times 3 by 1, right? So it's going to have 3 columns and 1 single row, right? So this single entry should be the small size, medium size, and large size. and this will just be the total number, whatever clothes were sold, right? So that's the case. So we figured out the dimension. So if it's 1 by 3, we knew this, the 4 will have to cancel. So the first one must be 1. So if that's the case, then this shape also looks a little bit wrong, right? So 1 by 4 will look like this. 1 row and then 4 columns, right? Okay, so now let's try to figure out how we can get there, right? So again, whenever we multiply matrices, there's 4 columns, so you use 4 hands. So go like that, we'll see, 4, and then we times it by the column, right? Now, so when we do that, so this times this, so when we do this times this, all this is going to be added up, right? So this times this, plus this times that, plus this times that, plus this times that, right? So 45, 30, 12, 15, all added up to one entry, right? Now, think of it this way. 45, 30, 12, 15, all these, what do they have in common? They're all under small size, right? Which makes sense, because I want total of numbers sold in small size. So in order for me to do 45 plus 30 plus 12 plus 15, the only way to do that, just like what we did before, is going to be 1, 1, 1, 1. Right? And hopefully I don't have to explain why. I made that pretty clear in C. So that's the case. And the next one, next column, right? 60 times 1 plus 30 times 1 plus. So essentially just 60, 30, 65, 40, add them all up, right? Those are all medium sold, right? So that's the case. And so that really covers D, really, right? So now the last part is the beautiful part, the E. Using the matrix X and Y that we've just found, right? What does Y and X mean? So what is it? So this is where I gonna scroll down a little bit. Yeah, there we go. So that's where it is, right? So 1 by 4, which is what we found in Y, right? And the middle one is the M matrix that we've been using. The last one is 3 by 1 that we used from part C, right? If we actually do all the, so before you even start multiplying the numbers, which is sort of useless because they're both are 1, look at the dimensions. 1 by 4, 4 by 3, 3 by 1. So let's actually multiply and see what happens. 1 by 4, 4 by 3. 4, 4 cancel, so it's going to be 1 by 3 if we do Y and M, right? Times 3 by 1. 3 cancels, so what do you have left? 1 by 1. Single entry. What do you think that means? Because both Y and X are all number 1s, right? So these numbers are not going to change. So somehow you add, when we first multiply these two, Y and M, you're going to be adding all the smalls, all the mediums, all the larges. And after that happens, it's going to be some by 3 by 3, right? It's going to be 1, 4, 4, 3. So it's going to be 1 by 3, right? So that's going to be all small, medium, and large, right? As we've seen over here, right? That's 1, 3, right? Now if I times it by 3, 1, all small, mediums, large, times together, right? So all small, so these are all 1s, right? So the 1, so we're just adding these 3, right? Because it's going to be this times this, plus this times this, plus this times this, except these are all 1s, as we found, right? So all small, all medium, all large, add them all up, and that becomes total number of clothes sold. That's all there is. So hopefully that clears up for people who haven't quite done it, or you know. But this was probably the most fun question, even if it gave me a little bit of headache when it comes. Well, like I understood this, but I wasn't sure what they wanted when they said X and Y. So it wasn't just, they didn't just want the dimension or the significance, they just wanted to know exactly what the entries were. Yeah, at least that's what I got from Carlos anyway. So, but yeah, fun question. It would be fun if we get this for the quiz. But anyways, that covers 1.3. I will try to upload 1.4 as soon as possible. I think I ran out of time for today, so, and the videos are still uploading. So I will upload 1.4 as soon as I can. Hopefully by end of today or tomorrow, possibly. Okay. Anyways, yeah. So study hard and make the most out of the weekend. You don't have to study that hard for this test, but you know, for future reference.